goal here is to take our XML user utility and be able to pass a user in, have it take that user as kind of a template and save it to an XML document. We want to be able to then essentially query out all the users in that XML document, update a user, save those changes back, delete a user. You can Now, to do that, we have a few options. There is an entire XML library within the .NET framework that allows you to go in and just literally read right from an XML document, bring it in, parse it, search it, do all this great stuff using XPath and XML schemas and all this jazz. It's great for poorly structured XML or very complex XML. But there's also, under the system.data namespace, there is a whole series of classes that allow you to go in and basically create an in-memory database that can then be saved and loaded from an XML document. And that utilizes what's referred to as a data set and a data table class. And that's the approach that we're going to use. So instead of dealing with creating attributes and elements and dealing with parent-child relationships inside of XML documents, we're going to take what I consider to be the easy route. And we're just going to use the in-memory database and then just save and load that in-memory database and let .NET basically do the work for us. Now, with all utility classes, I always do that. With all utility classes, I've found that you end up having these public methods that are your kind of view or abstraction to the work that you're doing. So these are 4 simple methods: delete user, update user, add user, get all users. Simple. But there's more work that needs to be done within the utility class than just maybe what's there at first blush. We have to be able to load an XML document, save an XML document. Those are 2 tasks that we need to be able to handle in this case. We need to be able to pack and unpack an XML element that represents a user, or a row that represents a user, into and out of their different states. So those routines are going to be functions that do small units of work that we don't want to have to keep programming over and over again. Now, sometimes with experience, you start to identify those units of work ahead of time because you always end up approaching those same units of work. Like when I'm creating a utility class for a database, I always know that I need to create a method that goes out and grabs the connection string for the database and creates a connection object, because it always happens. And I don't want to write that code inside of every one of these 4 methods. I want to write it once so that it's easily maintainable and I'm not repeating lines of code over and over. Probably for you, you'll end up finding those things that you can kind of shave off and put into functions, because you'll write it once all here under add user, and then you'll go to write another method and you'll go, why do I feel like I've already written half of this code? It's probably because you have. So looking at that and being able to then grab those chunks of code and moving them off into their own functions and just returning a connection object, or returning a command object, or returning a data set in our case, letting that be a call, a single call, makes your work and your time more efficient. And like I said, those are just things that you'll learn from experience. So what I'd like to attack right now is the add user. I'm going to move it up to the top here. So my approach is always to kind of carve out or define the steps that I'm going to take inside of my method just with comments. So it helps me remember, because when I get interrupted and I need to come back, I like to know what my flow is. It helps me to think through the process a little bit. And by doing that first, you end up with at least some semi-commented code. So it's a win-win. So in terms of adding a user, we're going to go through a process of getting the XML document, convert template user into data row, and save updated updated data set back to XML. 3 steps. Oh, and then step 4 is return new user with ID. So the end goal is I pass in this template user object, which basically has the properties that I need minus the ID field. The utility or the database engine, if it's a database, should have the responsibility of defining and giving the IDs or primary keys to most of your data. You don't want to be at the business layer doing that, because if that data layer changes, you may not be able to insert the ID. It may be auto-enumerated or auto-defined or auto-assigned by the database or the data access layer. So those are the 4 steps that we're going to go through for adding a user. So if we jump down here, I'm going to write a private dataset get dataset method. A dataset isn't recognized, and that's because I'm missing a using statement. So I'll add using system.data. So I've now brought in that namespace. And what this function is going to do is it's going to go through the process of retrieving or creating the XML data set that we need to actually kind of get this ball going. So I'm going to do a triple slash so I can do an XML notation and say that this method retrieves or creates the XML document that is our data set and returns the in-memory version of our data set. Make sense? Or in-memory version of our XML document. Okay, so get dataset. We'll start off by declaring a dataset variable. Now the dataset itself kind of functions as both a model class with data in it and a utility class. It's kind of one and the same. So off of dataset, you can call methods like load. And the load method will take in different sources. One of those sources is an iData reader that comes from the database schema for connecting to a database, opening a database connection, executing a query, and you can get back what's called an iData reader. Another option is that you can pass, that's an overload. So you have these different methods. I think I'm actually in the wrong method. What I want is read XML. My apologies. So the first overload just takes a string that is the file name. It also can take a system.io stream. So you go out somewhere else and you open up a stream to the file system or memory or somewhere, and you can take that stream and then actually open it. You can do a text reader, which is a reader that attaches to a stream. There's also an XML reader, which is a more customized reader. And then you have additional overloads of how do you want to open the file when you do, if you want to do it in read-only mode, read-write mode, shared mode, things like that. So for simplicity, I'm just going to put in here datastore.xml. Now doing datastore.xml, you're kind of like shooting fish in the barrel. You're kind of just winging it, because what what will typically happen is that wherever the exe file lives, that is the launch point for the application, that's where the data source.xml file should reside. So what that means to you and I is that when we finally put all this together and we build it, we hit that play button, everything compiles, it goes into a bin directory. That bin directory contains the exe file for our application, and then this data store.xml file will then get loaded or written to that same folder. In odd cases, when you're launching things as administrator and stuff like that, it sometimes will spin off and point to the Windows directory and you run into other issues. But typically, it lives next to the same place as your launching executable. We can get very specific within this if we want to, and we can actually pass in a parameter that says this is where the application lives, or we can set an app setting that says this is where that XML document should be stored. It's beyond the scope of this lecture, but those are things that we could do. So for now, we'll just go with this. One of the things that we should also check for is say if system.io.file.exists, which will basically check to say, does this file exist? So if the file exists, read from it. If it doesn't exist, we're just going to say, no, we just won't do anything. We'll just assume that we have a new data set. And in doing that, we'll then say dataset.tables. So we're going to add a table to our data set. .add. So if you think of the data set like a database, it's got tables inside of it. It has relationships between the tables, so you can build relationships. It really doesn't get much more complex than that, but then you also have rows inside of your tables and columns inside of your tables, so each table can have its own rows and columns. So it's literally an in-memory kind of database structure. So we'll add a table called users. And then we'll return dataset. So that simply goes through the process of loading or creating our dataset. So coming back up to add user, we'll say dataset ds equals get dataset. So I'm creating a local variable ds. I'm calling get dataset, which is going to go through that logic of actually going and getting the dataset and loading it. And then I'm going to need to convert my template object into what's called a data row. So we will create a method called build user data row. And it'll take in that template. And it'll return back a data row. Is because Visual Studio is smart enough to know and infer from this line of code what the function needs to look like. So instead of me going down, scrolling down and saying private data row, build user data row, parentheses user template, I just went ahead and wrote out the function as if it already existed. I can now go to that accelerator, click, and it'll ask me, do you want to generate a stub method for this method that you just randomly created? Sure. Okay, it now created the method. Or the stub of the method, right below it. Private data row, build user data row, user template. And then it puts in there an exception called not implemented. Because it's not implemented, it's just the stub. But it saves me a little bit of work. Now, the caveat here is to create a new row, I have to create that row based on the data table that it's going into. And right now I don't know much about that table. So I'm going to actually add a second parameter here that is the data table. You'll see why in a minute. Now, because I made that change, I'm going to have to jump back up here. And I'll also have to pass that table in here. So to get to that table, I'm going to say ds for the data source, dot tables. And then just like an array, I'm going to use square brackets. But inside of these square brackets, I'm going to put in the name of the table, users. So I'm now passing in the template object and the table. So to create or to build that user data row, I'm going to create a new row. I'm going to add data to the row, one column at a time. Save the row to the table, and then I'll go ahead and return the row. So to create the row for a data table, it's data row, new row, I'll call it that, and then we'll say the insert table dot new row. So there's a method off of the data table that's called new row, and that will generate that new row object for me. So I don't come in here and say data row new row equals new row. The table will give me a row. So in normal fashion, we'd say new row, first name, that's the name of the field, equals template.first name. New row, last name, equals template.last name. New row, email, equals template.email. New row, password, equals template.password. Now, this is part that's an interesting nuance. I always forget that you create the row by using the table, but the row is not attached to the table until you explicitly attach it. So we basically have this row object that's independent of that table, even though the table gave it to us. We've populated it with data, and then we actually have to pass it back to the table and say, okay, it's populated, added as a row to the database. So we say insert table dot rows dot add new row. And then we can just go ahead and return our new row. Now there was one step that I forgot to do. I have these fields, these columns in my database table that I never actually defined. So I'm going to go back down to get dataset and see here where I created the table. I also need to add my columns here. So when you call add, aside from passing in a string, it also returns to you a data table object. So I'm going to say data table, users table. So I'm actually going to capture that. Users table dot columns dot add. And now there's add and there's add range. Add range takes an array of data column objects. Add has a bunch of overloads. You can just call add and it'll give you just a straight data column with no attributes, no values, no properties. It has properties, but they're empty. Or you can pass in a data column, so you can do like a blueprint. Or you can pass in the column name as a string. And that'll be the approach I'll take. So first name, copy, paste, paste, paste. Last name, email, password. So we've now added columns to that data table. So we've gone through and we've built our data row. Let me actually take this and move it down here. Typically, I like to put all of my private methods together and my public methods together. It's a preference, but it's just that idea of public, here's the stuff that other people see, and then private, here's the stuff that's private. Kind of just within this class only. There are little add-ons you can add to Visual Studio. They'll go through and sort like that, or they'll sort how you want. They'll put your fields at the top, your publics in first, your privates next, and then sort them alphabetically. If you're type A, you can download that and do that. I always think that's a great ideal, but I don't care that much. So, all right, so we have that new row. It's been added to our data table. We can then turn around and save data set. We'll pass that data set back in. And again, this method doesn't exist, so I'll use my accelerator and I'll generate that method stub. I'll go ahead and take this and move it down to the bottom. And now the process here is to take that XML document and or that data set rather, and write it back as XML. So we'll say ds.write XML, and then it'll be data source.xml. It's as simple as that. Now, this data source, if you're thinking this question, this data source is not transactional like a database would be. So it's not like 3 people can be hitting this data source at once and inserting and updating and deleting records without stepping on each other. It is still a flat file at the end of the day. So if person A writes to the file and then person B maybe reads from that file before it gets written back to, they're only going to see part of the transactions. They're only going to see some of those users. Someone goes in, person C then deletes a user, and then someone else goes in and updates that user and writes over it. Well, the delete will happen, but then the update will put that user back in. Yeah.
Does it have to be like an XML file, like extension, or can it be like a text file? Or does it really matter?
The extension doesn't really matter, but typically you put .xml for XML documents. But if you're trying to kind of be, like if you're trying to hide that it's an XML document, you can use a different extension.
Okay.
But the system doesn't care. But it's just that's typically what you do with XML documents. You do .xml. But yeah, it'll let you do whatever extension you want, or even no extension. Okay. So that's our add. So let me go ahead and do this. Let's jump back to our Windows app, and I'm going to add a reference to our data access layer and to our business layer. So I'm going to add both references into here. And then we'll go back to our add user form. And we'll go to our save method. Now, this approach is not a full abstraction. I'll preface by saying that. But you'll still get the sense of how the abstraction kind of works. And then we're going to actually do a full abstraction where we decouple the data access layer completely from the UI, from the presentation layer next week. So in here, what I'm going to do is I'm going to say XML user utility. User util equals new XML user utility. And I'll add my using statement. So that now really exists. And then I'll say user new user equals new user. add my using statement. So those are my variables. I'm not going to go through, but typically you would put your validation in here, just like we did last week. So new user object at first name equals txt first name.text. New user object dot last name equals txt last name.text. New user object dot email equals txt email.text. New user object password equals txt password.text. So we've now loaded up our object, and I'm going to break convention just for tonight. So instead of taking this object and passing it back to the main form, I'm just going to go ahead and do the add straight here. So add new user to util, or via utility. So this will be user util dot add user. So if you remember, this is our class. This is our utility class that we made. So it's got our add user, delete user, get all users, update user. It's all built right in. So we'll say new user object. And that's it. And if we want to, we can say this dot close. Close the form. So it's a lot simpler. We didn't have to put all that XML code in and do all of that stuff. We just had this utility class, and we just do create the object, add the user. So if I jump back to my main form, add user, I'm going to say add user form equals new dot show. I'm going to go ahead and do a show dialog because I don't have my events in place to trigger back that it's done. And then I'm going to go ahead and stub out a new method called refresh data list. And this will pull, let me zoom in here, pull users from user utility, bind users to the lists, refresh. So that's the idea. So go ahead and hit play. So we've got our form. We'll hit add user. And as we're doing this, I'm actually going to pull up my file explorer so you can see what's happening. So we'll do Solution Explorer. I'm going to right click on this project and go to Open Folder and File Explorer. When you build your projects, they go into the bin directory. Since we're in debug mode, they go under the debug. And you'll see here a few things. Let me try to zoom in here so you can see it. So there's the 15sscp mod4.exe. That's our UI or presentation project. When it gets compiled, it turns into an exe. You'll also see that we have mod4 business layer underscore core.dll. That's that mod4 business layer project. Mod4 data access layer.dll. That's the data access layer project. So they get compiled into DLL files. And since they're referenced by the executable, they then get brought into this bin directory. Now, each one of these projects has its own folder. Each one of those folders has its own bin directory. So what happens is that same process, and then its dependencies. This business layer project is independent. So when it builds, it basically puts in a DLL, and you get this PDB file. And I'll talk about that in a minute. Data access layer project, debug. We end up with 4 files in here, 2 DLLs, 2 PDBs. There's the business layer because it's a dependent. Our project is dependent on the business layer, so it gets compiled and brought in, and then there's the data access layer. The same thing happens with the UI. Both of those projects get built, and then those DLLs get sucked into the bin directory of the EXE or the presentation project. The PDBs are called debug symbol files. They're used by Visual Studio. So when you're in debug mode, this is compiled or intermediate language compiled code. In order for Visual Studio to know what line of physical code that executing code is, the PDB helps make that relationship by building what's called a symbolic link between the actual executing code that's compiled and the source that you built from. You can not do any sort of real-time debugging without the PDB files. So you have to have the PDBs in order to do debug. So when you do a release build, PDBs are generated, but you're more restricted because your release build goes through a series of optimization processes, and sometimes certain variables get abstracted away because of the optimization in the compiler. So if it sounds interesting to you, you can go look it up for more details or ask me later. All right, so I want to stay in there because I want to see what happens. So Kevin, Gantos. So what should happen is I click save. Our code will execute, and I'll actually jump into here so you can kind of watch the execution path. I'm going to go through a debug. So I put a breakpoint here inside of my button click, and then we're just going to step through it. So I'll click save. We start at this line. I'll then step over. So we now have a user util object. We have a new user object. I'm pumping the data from my form into my user object. So there's all my form data. I'm now going to go ahead and step into this method, the add user. So the first step will be to get the data set. We'll step into that. So we create a new data set variable, new object. We check for the data store.xml file if it exists. It doesn't. So we go ahead and we assume that we have a new data set. So we create a data table. We add it. We add columns to that table. So if we peek into the data set now, we can expand and we'll see all these properties, including the data tables property. We twirl that open, and we have this result view. If we hit the refresh here, it'll expand, and we'll actually see that we have one table. This magnifying glass allows us to have a built-in kind of like Microsoft SQL Management Studio view of that table in memory. So if we hit that, it'll actually pop open what gives you the impression of a database table. Now there's no rows in here, but we have our columns, as you can see across the top. So this data table is currently empty. There are no rows. But it does have that table structure. So we'll go ahead and walk down. And I'm going to go ahead and step out, which will bring me back to the caller, what function or what line called this. So it brings us back here. I'll now step over, and then we'll go into the build user data row method. We'll call new row. Excuse me. This item array represents the row or the columns. So we'll go through and we'll pump all that in. Now you'll notice that these are indexed instead of giving you the column names. In the row, the data doesn't really know about the column. Because the row object is a member of the table. The table has a collection of columns. So what happens is that each column has an index position in that collection, or in that array, if you want to think of it that way. Position 0 in the data column collection is first name. Position 1 is last name. Position 2 is email address, and position 3 is password. So when you say, go get me the first name column, it actually is doing a little bit of math and trying to identify the name of the column, finds the position or index of the column, it finds the position or index of that row column value, and then returns you the value. So there's a little bit of work that actually goes on that you don't really see. That abstraction happens. We'll take the row, add it to the table, go ahead and return the row. I'll step over, kicks me back out. And then we'll go into save the data set. We'll jump inside of that. It's a one-liner. We write it, step out. If we come back to the file system, there's our data source.xml. If we peek inside of our data set and we twirl this open again, go down to data tables, twirl it open. Whoops, sorry. Okay, fine. We can also hit this magnifying glass here. It'll give us our tables. And then you can actually toggle between the tables if there's more than one. So there's our row inside of our data table. If we come here and we open this, I always use Notepad++. No, I do not want to download updates. No, I do not want to download updates. So there's the data, or I'm sorry, the XML that was generated from our data set. So it takes our table name and creates kind of this nested element called users. We can actually give our data set a name, and that becomes the top level node. And then here are our properties serialized into XML. We'll go ahead and do that. So we've now added our user. All that happened in that one line of code within our UI. We'll just continue through. That form closes, and it's done. The refresh happens, but there's no code for the refresh. So now we need to write the code to do our refresh.